Okay, moving on to properties of matter. And I didn't mention this earlier, but you might have noticed I've got hyperlinks in each of the top of these headings, and those go to the textbook in case you want to read it, okay? All right, so there's different properties of matter. There's going to be physical properties and chemical properties. We're going to start with physical properties because those are the most simplistic. These are any characteristics that can be observed without making a change to it. So if you have a substance, you should be able to observe or measure a physical property. So this could be the mass or the volume or the melting point, something that you're not changing the chemical to actually get this measurement. Now, physical properties can also be broken down. There are extensive properties and intensive properties. So an extensive property depends on the amount of substance you have, i.e. mass, volume. Okay, if you have a substance and you measure its mass, it's going to change when you have different amounts, right? If you have 2 grams versus if you have 5 grams, you have a different mass for different amounts, a different volume for different amounts. Intensive properties, however, are things that do not depend on the amount. So the melting point, whether you have 50 grams of ice or 1,000 grams of ice, the melting point for ice is always 0 degrees Celsius. Okay, so melting point does not change depending on the amount. Same thing with density. The density of a substance is always the same no matter how much of it you have. That's why density can actually be very useful. That's why density is actually very useful. Things have fixed densities, so you can actually identify substances based on their densities. So I have some examples of extensive versus intensive properties up here to kind of give you something to reference. Okay. All right, physical changes. We already talked about examples of physical changes are going to be a change which doesn't affect the actual chemical. It changes just the form of matter, not its identity. So an example of that we said before was changing the state of matter. So something that is melting is a physical change. Also, if you dissolve something, that would be considered a physical change. So salt, for example, NaCl solid and NaCl dissolved, that would just be a physical change. One, you can get it back. That's kind of a good way to think about it. And also, it still has the same properties, right? It tastes salty. It's still NaCl. I didn't change the formula by any means. So dissolving would be considered a physical property. Ripping a piece of paper, physical change. The paper is still made of the same stuff. Okay, so those are physical properties and physical changes. So we're going to switch gears to chemical properties and chemical changes. Okay, so a chemical property is a characteristic that could be tested with a chemical reaction or change. Remember, we said physical properties you can see or observe without chemically altering it. Chemical properties, you have to actually chemically alter it to see if it has a specific chemical property. For example, the only way to test if something is flammable is to actually light it on fire, and that would be a chemical change. So flammability, acidity or basicity, reactivity, any of those things are considered chemical properties. Now, a chemical change, on the other hand, is that reaction when you're actually changing the chemical formula. Whenever you break or make new bonds, it's considered a chemical change. So if something is rusting, that would be considered a chemical change. Burning wood would be considered a chemical change. Okay, so just make sure you're using those terms correctly. A chemical property versus a chemical change. Well, to find a chemical property, you might have to undergo a chemical change. Just make sure you're using the terminology properly. Okay, so example number 2, would these common daily activities classify as a physical or a chemical change? I want you to give this a try and then check your answers. Okay, so getting a haircut is just changing the shape of your hair. That should be considered physical. Applying bleach to turn your hair blonde is a chemical change. A lot of the time, a color change indicates a chemical change. Baking a cake is a chemical change. You're actually causing a chemical reaction to occur when you're heating it up. Adding Crystal Light packet to water would be a physical change. Remember, I said dissolving is a physical change. Leaves on a tree turning red or yellow is a chemical change. It's actually a different chemical that presents that color. Rubbing alcohol evaporating from your skin would be physical. Evaporation is just turning from liquid into gas. That would be a phase change, so it's physical. And pouring spaghetti sauce over pasta, I didn't make any chemical alterations. That would also be a physical change.